The objective of the problem is to find the maximum for a sliding window. So if the numbers are given like this and a window is given, what we need to do is we need to find an output like this. This 3 is like the window is 3, so we have 3 window which keeps moving. Like in this window the maximum is 3, in the next window the maximum is 3, the next window the maximum is 5, so on and so forth. So how we sort of solve the problem is by having a list. What we do is we loop through every element of the array, of the input array, and what we do is I'll come to this later. So what we do is, if the list is present, the objective is to insert this element into the list. But while inserting, what you have to do is we have to insert. We'll be inserting at the end. So what we'll be doing is we'll be inserting at the end. So what we'll be doing is we'll be popping every element that is at the end, which is less than our element. If you could see, we can see that we are inserting by indexes and not by values. So what we do is we find the last elements. This is the index of the last element inserted. So we find the number which is inserted at the last, and if it is less than the number, we pop that out, and we keep doing it till we find a number, an index that is corresponding to a number which is bigger than n. So we keep doing it, and once we are done, we will come out and we will insert the index of the element onto the list. And this is to just to print the output. If you could see, there are we have to start printing. We have to start outputting from this point. Since case 3, we have to start inserting from the second point. So here we have to start when I is greater than or equal to k minus 1. So if it's 3, we have to start from 2 and keep appending the output to that of an output. This is the output that we will be giving out. So I can do out dot append of the number. Okay, this is to take the elements that are at the top of the list that are not useful to us. So if we are at ith position, let's suppose we are at the third position, and we want, let's suppose we are at the fourth position, 0, 1, 2, 3. We are at the fourth position, and the indexes and the number that we are interested, and the k that we are interested in is 3. So we have to take, let's suppose when we are looping, we have to take this element out. So suppose we are looping, when we are on the fourth position, that is the loop 3 minus 3 will be 0. D of 0 will correspond to the first element. If suppose the first element, which is 0, this first element, if it's there in the list, we have to pop it out. So this loop is just to take the elements that are less than or equal to I minus k. Actually equal to itself, and because if you are doing it once, it will continue, right? So there will be no, less than number will not be there. So if you have an I minus k, if you are this is to just take the old elements out. So if you could see, you can just add a dummy number and see if input like this, and if you run this, the output is 7, 6 by 4, 3. It's 7, 6, 5, 5, 4, and 3, because the number is 2. If you could see, if I can actually print here, the first is 0, the second element is inserted because it is less than 6 is less than 7, so it is inserted. When we are coming for 5, we will be at the second I will be 2. and our interest k is equal to 2. So at this point what we'll do is we'll pop this out, and then we'll have 5, so insert 5, and then insert the index of 5, which is 2, and then we'll have incoming 4. When you're coming for the 4, the index will be 0, 1, 2, 3, so we'll pop this out. So that's how it is. It's simple, but to get this logic, it may take some time. Thank you.